Welcome to Mrs. Thompson's classroom. Today we're going to be doing some more problems with functions. In particular, we're going to learn how to combine them. So we're going to do some addition, subtraction, multiplication, division of functions, as well as determining their compositions of functions. So let's get started just with some basic evaluation of functions. We need to get a little more familiar with function notation in order to do the rest of our work. So this notation simply tells me that -2 is my x value. So I'm going to replace every time I see an x, I'm going to replace it with -2. Okay, now I put the parentheses in there to make sure that I'm putting the -2 inside whatever is being done to x, okay? So -2 cubed is -8. -2 squared is 4. So now I have -8 minus 8 minus 8 plus 1. So I have, let's see, that's -24 plus 1, that's -23. Okay, so in part B, now I'm going to let x equal 2. So I'm going to have 2 cubed minus 2 times 2 squared plus 4 times 2 plus 1. So now I have 8 minus 2 times 4 plus 4 times 2 plus 1. So that gives me 8 minus 8 plus 8 plus 1. So that gives me a grand total of 9. So notice those parentheses were important because if it was a -2 and it got cubed, that became a -8. Okay, but a +2 cubed, +8. So we got to watch our signs. Okay, so now this one tells me I'm going to take x plus 2 and I'm going to put inside there. So I'm going to rewrite f, putting those parentheses where I see an x, and then I'm going to replace it with x plus 2. Okay, and this is what we mean by composing functions. I'm putting a function, x plus 2, inside another one. Okay, and then of course we can multiply that all out, and we are going to get some practice at doing that. Okay, if I'm going to put -x in it, then I'm going to do -x cubed minus 2 times -x squared, 4 times -x plus 1. So I will go ahead and simplify this. If I cube a negative, that's going to be -x cubed, but -x squared is a positive, so that's going to keep the sign of negative on the 2. 4 times -x is a minus 4x plus 1. Okay, so when we're evaluating functions, we're just replacing the x with whatever number or value function, whatever they've put inside those parentheses. Okay, so now let's start combining some. In example A, this just means I'm going to take f of x plus g of x. Functions are commutative and associative, so I can add them in any order. I can multiply them in any order. Okay, so, but this plus inside here, this notation right here, just means I'm adding the two functions together. So that means I'm going to take f of x, and I'm going to add g of x. And then when I combine all my like terms, I get x squared plus 3x, and -3 plus 3 goes to 0. Okay, example B just means I'm subtracting the two functions. So I'm going to have f, and then I'm going to subtract g. Now I'm subtracting all of g, so I need to distribute that negative through there in order to combine like terms. So I get -x and -3. And now I can combine like terms. I get x squared plus x minus 6. Okay. And example C, I am multiplying the two functions together. So I have x squared plus 2x minus 3 times x plus 3. Now if I'm going to multiply this one out, I have to multiply everything in the first one by everything in the second one, or vice versa. So I'm going to take the x and distribute it through. So I'll get x cubed plus 2x squared minus 3x. And then I'm going to take the 3 and multiply through. So I get plus 3x squared plus 6x minus 9. Now I can combine my like terms. Okay, 2x squared plus 3x squared is 5 of them, minus 3x plus 6x is a 3x, and then I have the minus 9 on the end. Okay, in D, this just means I'm going to take F and I'm going to divide it by G. So one thing I want to watch out for when I do the division is to see if I can reduce the fraction. Notice this numerator factors. This would give me x squared. The outside and inside would make 2x, and 3 times negative 1 makes negative 3. And so this does reduce. So my answer is x minus 1. However, this being in the denominator tells me x cannot equal what? Well, x plus 3 cannot equal 0, which means x cannot equal negative 3. So we're going to restrict the domain. Okay, now all the rest of these are based on polynomials. X squared plus 2x minus 3, x plus 3. Those are polynomials. The domain of these is all reals. Okay, but when we divide, it changes that domain. Okay, all right, on example 3, we're going to take these two functions. It wants us to find the sum of them. So I'm simply going to take f and add g. Now with addition, I cannot combine square roots unless what's underneath is identical, and it's not. So this is my answer. Okay? However, it says to find the domain of all three. So the domain of f is x such that x has to be greater than or equal to negative 2. Okay, because remember, x plus 2 has to be greater than or equal to 0. Okay, in G, x minus 1 has to be greater than or equal to 0. So the domain of G is x greater than or equal to 1. Now for f plus g, I have to follow both of these restrictions. So let's put them on a number line real quick. Here's negative 2, and here's 1. I'm going to go greater than both of those. And the final restriction is where they overlap. So my domain of their result is the red line there on greater than or equal to 1. So my domain of f plus g actually matches the domain of g because it's more restricted. Okay, so we have to check the domain of the original functions in order to predict the domain of the new function. Okay. All right, let's do some more of these. Now, these are composition functions. Now, composition functions are where we're going to take one function and put it inside another. There are two notations for this. Okay, so, but they are both read f of g of x. So I'm going to put x into g and then put that into f. Okay, so on example A here, this is taking g and putting it inside f. So I'm going to take f. That's the function f. And then I'm going to put g inside it. Okay, now let's go ahead and simplify this one. When I square this out, that's like multiplying it by itself, right? So I need to FOIL. So that's going to give me x squared minus 4x plus 4. I'm going to distribute this -2. And then I have plus 1 on the end. So my final answer is x squared minus 6x plus 9. Now, everything I used, both f and g's, domain is all reals. So the domain of the end result is also all reals because it is also a polynomial. Okay? B wants me to take h and plug g into it. So I take function h, which is the square root of x, and then I put g inside. So now the domain of that, it has to come when x minus 2 is greater than or equal to 0. So that's the set of x such that x is greater than or equal to 2. All right, C wants me to do f of h. So I take f and I put h inside. Okay, when I square a square root, it does become, this square has to be a positive. So regardless of what x was to begin with, I'm going to put absolute values there. However, the domain of h was everything greater than or equal to 0. So as long as I state the domain, the absolute values are not necessary. Now the fact that f of h still has this square root in it would tell me that this domain restriction is required. But we do want to go ahead and put that restriction. We always want to state our domain anytime we're dealing with root functions, square roots in particular, and rational functions. Okay, f of g of 1. Now, if we look back at example A, I already found f of g. So f of g was x squared minus 6x plus 9. So now I can just put 1 into that. And I get 4. Now you can go back and put 1 into g and then take that result and put it into f and you can build it. But since we had already found f of g, this is a much quicker way to go about it. Okay, now here's another one. They want us to find f of g. So I'm going to take f. It's x over x squared minus 1. And I'm going to put g into that. So I have 2 over x divided by 4 over x squared minus 1. Now that's a fraction within a fraction. We're going to need to simplify this. So really what we have is we have 2 over x divided by 4 over x squared minus 1. So the first thing I'm going to do is I'm going to try to do this subtraction, which means I need to get a common denominator. So I'm going to write the 1 as x squared over x squared. So this ends up being 2 over x divided by 4 minus x squared over x squared. Now we divide fractions by changing it to multiplication and using the reciprocal. And now I can reduce. So I end up with 2x over 4 minus x squared as my end result. But we need to watch the domain. So from the very beginning right here, I know x cannot equal 0. That's the domain of g. the inner function. From the end result, I can tell that 4 minus x squared has to be greater than or equal to 0, which means that negative x squared has to be greater than or equal to negative 4. And so I end up with x, okay, this less than is going to actually give me, it's got to be between negative 2 and 2. Okay, so my domain, so this is the final function here, and the domain is x such that x is not equal to 0 or x is between negative 2 and positive 2. Now what that really boils down to is negative 2, and actually this is equal. So negative 2 to 0, union with 0 to 2. Okay? All right, so whenever you're dealing with roots and rational expressions, always double check your domain and look at the original as well as the result. Okay? All right, decomposing them. Well, this just means that we know h, we're given some function that we know is a composition, and we're just going to try to figure out what the inner and the outer function are. So if h of x is equal to f of g, my inner function here is the 2x plus 1. The outer function is this fourth power. And so I'll just put an x in there. So inner and outer. So on part B, if h of x is f of g, then the inner function is the x cubed minus 1. And the outer function, is the square root. Now, sometimes there are more than one way to decompose it, and so you might have an answer that looks different from your neighbors, as long as when you compose them and you put them back together, they get the end result, okay? All right, so that is where we're going to stop for today, just learning how to put functions together, or combining them in some form or fashion. So hopefully you get some practice on that, and I will see you in class next time.